All right, so what we're going to do here is we're going to take the exam together. Just so you can show, or I'm sorry, just so you can see how I was doing the exam, how I would want you to do one of these problems, and just so, you're clear on what was going on. Okay, so right off the bat, we're going to start with highlighting. So we have 10 ounces, 35%. We have a stock solution that's 50%. How many mils of 50 and how many mils of purified water are needed? Okay. So right off the bat, I know that's an alligation because I'm trying to make something. So I'm going to start with my desired in the middle. So we need 10 ounces of a 35%. We have 50 in water. So 50 minus 35 is 15. 35 minus 0 is 35. 35 plus 15 is 50. So just remember, so it's asking for mils, but we need 10 ounces. So if you remember, 10 ounces is how many mils? Well, it's 10 times 30. 300 mil. Okay, so I have 35 over 50 times 300, and I have 15 over 50 times 300. That's 210, and this one is 90. And just to double check, that's 210 plus 90 is 300, so that makes sense. So that's 210 mils of 50% and 90 mils of water. Right? Okay. Next one, we have hydrogen peroxide stock solution available 3.5%. How many mils of stock solution and water? 120 mils with 2.5. So it's another alligation. Okay. 2.5 is our desired. And we know we have water and a 3.5. Okay, so 3.5 minus 2.5 is 1. 2.5 minus 0 is 2.5. So that's over 3.5. How many are we trying to make? We're trying to make 120 mLs. Okay, so that's 2.5 over 3.5 times 120, and that's 1 over 3.5 times 120 as well. Whoa. That is 34.29. Okay, 86 mils of 3.5, 34 mils of water. Got it. Okay, switching gears to an rate of infusion. 30 mg per minute for 24 hours. So we got a rate and a time. Total dose in grams. Okay, so if we're getting 30 milligrams per minute, and there are, okay, 1 second, let me write that again. Okay, we're doing 30 milligrams per 1 minute. Okay. On this side, I'm going to go ahead and convert into hours because I know that there are 60 minutes and I don't know how many milligrams it's going to be, but that's 30 times 60 divided by 1, but that's 1,800 milligrams per hour. Okay, so that's milligrams per hour, but it wants it in grams. Okay, so if we have 1,800 milligrams, we don't know how many grams that is, but we do know our conversion factor, which is 1,001, and so that's 1,800 divided by 1,000, and that's 1.8. Oh, whoa. Oh, you see what I did? So the 1,800 per hour, so I just calculated 1.8 grams per hour. So 1.8 times 24. And by the way, you're welcome for making this multiple choice. I would have just got the wrong answer. 43.2 grams per day. Okay. So that 1.8 that I calculated was basically just in 1 hour. So it's 43.2 per day, 24 hours in a day. Okay, this is a weight-based, 52 pounds, 50 mg per kg per dose every 8. We have it in 100 mg per mil. Okay, first step is obviously we have a 52-pound patient. We need to know his weight in kilos. We know that there are 2.2 pounds in 1 kilo. So that's 52 divided by 2.2. And that is 23.64 kilos. He needs 50 mg per kg per dose, okay? So we can solve just one dose, okay? If he needs 50 milligrams for every 1 kilo he weighs, he does not just weigh 1 kilo. He, in fact, weighs 23.64. We don't know how many milligrams he needs. So it's 23.64 times 50. And I got 1181.8 milligrams. But just remember, that's per dose every 8 hours. Okay. So how many mils are required for each dose? So we don't need to convert that. So we just need to know how many mils of our product, which is 100 milligrams per mil, we need to provide to give him his dose of 1181.8 milligrams. Okay, so it's basically just 1181 divided by 100, and I got 11.8. We'll call it 11.82 mils, and there's the answer. All right, he receives 2 grams in 250 mils. The rate is 30 milligrams per single minute. How long in hours and minutes will it take to receive the infusion? Okay, so if it says 2 grams, 250 mils, and it's also saying 30 milligrams per minute, I know I'm going to need to convert to milligrams. So 2 grams is how many milligrams? Well, we know it's 1 gram per 1,000 milligrams. 2 times 1,000 is 2,000 milligrams. In how many mils? It is in total 250 mils. Okay, so if I do this calculation, it'll tell me how many milligrams are in 1 single milliliter. So I'm going to do 2,000 divided by 250, and that is 8 milligrams per mil. Okay, so that's how long it's flowing. How long will it take to receive the infusion? Oh, okay. He needs 30 milligrams per minute. So how long or how many mils do we need to have of our product to get 30? Okay. So we have 30 milligrams. We don't know how many mils, but we do know that there's 80 in 1. Sorry, 8 in 1. So it's basically 30 divided by 8. That is 3.75 mils per every minute. Okay, so if we have 3.75 mils per minute, we have 250 mils. So I'm going to do 250 divided by 3.75. That is, let me write that down. $66.67 minutes. Okay, so this is where things get tricky. We have to remember that how many minutes are in an hour? There are 60. So I'm going to go ahead and subtract 60. So 66.67 minus 60, which is an hour. I'm left with 6.67 minutes. So we have 1 hour, and that's our best answer. Okay. So we have 0.66, sorry, that's actually, yeah, that's minutes. Okay, so just don't get confused on when it says minutes or hours. We have to remember there are 60 minutes in an hour. Okay, patient order 1,000 mils, 75 minutes. What's it in mils per hour? Pretty easy because we have to do 1,000 milliliters, 75 minutes. This is going to tell us exactly how many milliliters of our product is going out in 1 single minute, because we're not changing the rate. Because if we ask ourselves, okay, how many is in 1 minute, then we can just multiply by 60 and say, okay, this is how much in an hour. So that's what I'm going to do. 1,000 divided by 75 is 13.33 mils per 1 single minute. Okay, we already know that there are 60 minutes in an hour. So our minutes cancels and we're left with mils per hour. So what's 13 times 60? And that is basically 800 mil per hour. Is that an answer? Yes, it is. Okay, day supply. I'm not going to highlight because really right here we need to focus on, okay, how much are we giving them? I'll go ahead and highlight. We're giving them 20. Okay, so when you're confronted with 2 times, so when it says 1 to 2 or 4 to 6 hours, you are going to ask yourself, okay, if he takes it the most that he can, how long is it going to last him? So if we say, what is the most tabs he can take at once? That is 2. Sorry. That is 2 tabs. So every 4 to 6 hours. So which one happens more? So 4 hours, every 4 hours happens more frequently, right? There are 24 hours in a day. So 24 divided by 4 is 8. No, I did that wrong. It's 6. So it's 6 times a day. So if he takes 2 tabs 6 times a day, that is basically 12 tabs a day. Okay, and we only gave him 20. So we need to do our 20 tabs divided by 12 tabs per day. All we'll end up is tabs. Okay, I'm sorry, days. 20 divided by 12 is equal to 1.67 days. Remember, fatal mistake here. If you round it up, it will short the patient. You always round down on day supply, so that turns into 1 day, which is wrong. So I will fix that. Yeah, that is wrong. It should be 1 day. Okay, I will fix that. Drug ordered, available 0.5 milligrams per mil, orders a dose of 25 micrograms per kilogram, 160 pounds. Okay, I know that I'm going to need to convert his weight first off, which is 160 divided by 2.2. 160 divided by 2.2 is 72.73 kilos. Okay. He needs, 25 micrograms per kilogram. So I'm just going to multiply that by 25, and that is 18.18 micrograms. Okay. So it's in milligrams per mil, so I'm going to go ahead and calculate that in milligrams. So if you remember, we have 18.18 micrograms. We need it in milligrams. And this is the conversion factor. So if you remember, micrograms is 1 million, milligrams is 1,000. So basically, it's a 1,000 to 1 ratio. So we have 1,000 of these is equal to 1 of these. So it's the same thing as moving the decimal 3 places left. So 1818 divided by 1,000 is 1.8, we'll call it 82 milligrams. It's 0.5 per mil. So we need 1.82 divided by 0.5. So we need 3.64 mils. Perfect. All right, so this one. Anytime you see D something W, it's going to be dextrose, that percent in water. NS is normal saline, which please memorize the percentage because I will quiz you on this. It's 0.9%. LR is lactated ringers, which is just an electrolyte solution. Not super important that you know exactly what it is, but know what the abbreviation means. This means sterile water for injection. Okay? All right. Rate of infusion problem. So we have 45 mils an hour. Bag of 1,000 mils is hung on day 1 at 0400 hours. When will the next 1,000 milliliter bag be needed? Okay, so it's basically a rate of infusion, and we need to know if it expires and when to replace it. So we have 1,000 mils going at 45 mils an hour. Okay, so how fast is it going to be depleted? So 1,000 mils divided by 45 mils per hour. That's going to tell me how many hours it's going to take. 1,000 divided by 45 is equal to 22.22 hours. Okay, mils cancel. Okay, so 22.22 hours. Really, I need to ask myself, okay, how many minutes is that? Because the question is saying hours. You know, I need to know if it starts at 0400, how many hours and minutes away is that? So I know it's 22 hours. So 0400 plus 2200, because 22 hours is the same thing as 2200. I'm going to add those together. And I'll get 2600 hours. But you know, in military time, you only go to 24. So what that will mean is it's going past, it's going to 2 on the next day. So we start at 0400. It's going to go to 2 o'clock the next day. So 0200 the next day. But remember, we had 0.22 hours. So 0.22 hours. And we need that in minutes. Okay. This is our proportion. So it's 0.22 times 60. That's 13.2 minutes. So we're looking for 0213. Okay. Because 0200 plus 13 minutes is 0213. Okay? That is how we got that answer. Day supply, we're giving him 60. He takes 1 4 times a day. So if he takes 1 4 times a day, 1 times 4 is 4. He takes 4 tablets a day. And we're only giving him 60. So 60 divided by 4 is 15. Perfect. Didn't screw that one up. Okay. 250 ml bag, infused at 40 drops per minute. It's 60 drops per mil. It started at 6 a.m. When is it going to be needed next? So we have our drop factor and how many drops per minute are going. So we have 40 drops per minute, and there are 60 drops in 1 mil. So, oh man. We need to know how many mils that is. And my conversion factor is 60 per. Okay, that's going to tell me how many mils that is. That's 40 divided by 60. And that means for every minute there are 0.67 mils going by. Because we started with 40 drops per minute, we needed to ask ourselves how many mils that was. That's 0.67. So that's per single minute. Okay, so if I need hours, no, I don't need to do hours. That's 0.67 mils per minute. Okay, we have 250 mils. And we're pushing out 0.67 mils per hour. This calculation is going to tell us how long that's going to last. And it's going to last for 37 point, I'm sorry, whoa. Oh, you see what I did? I did not convert that to hours. Once again, times 60. So 0.67 times 60. So what I just did was wrong. This will be 40.2 mils per hour. So if I did it the other way, I would just have to divide it by 60 again because I was in minutes. But 40.2 hours, and and we have 250 mils. Once again, saved by multiple choice. So 250 divided by 40.2 is going to be 6.22 hours. When did we start it? We started at 6 a.m., which is the same as 0600 hours, and we need to add 6.22 hours. Okay, but just remember, 6.22 is not the same as 622. So 0.22 hours that's 13.2. So I need to add 0613. 0600 plus 613 is 1213 hours. Okay, so there was a rounding issue, but 1215 is obviously closest. But remember, I threw in a little trick right here, right? Do not pick this. Okay, it's that. Because 12:15 a.m. is the same as 00:15 hours. Okay, because that's at the start of a brand new day. 12:15 is the same thing as 1215 hours. So that is our answer. I put that there for a reason. Okay. Continuous infusion rate 3 mils per minute, 1,000 mils. 2 grams are ordered. How many milligrams will they receive in 20 minutes? Okay. Okay, we have 2 grams. I know it's going to be converting into milligrams already, so I'll go ahead and do that. I'm not going to write it out anymore because I'm just going to save some time. 2 grams is 2,000 milligrams. And what volume is it in? It's in 1,000 mils. (2,000) divided by 1,000 is 2, and that is milligrams per mil. So they are ordering it at 3 mils per minute. Okay, so there is 3 mils going by every minute. Okay, so if there are 3 mils going by in a minute, sorry, I wrote that wrong. If there are 3 mils going by in every minute, we need to ask ourselves how many milligrams is in that. So we have 2 milligrams per 1 mil. I flip that. And there are basically 6 milligrams per mil going by. I'm sorry, per minute. Okay, 3 mils are going by every minute. We know our drug is containing 2 milligrams for every one of those that's going by each minute. So you could basically say that we are giving him 6 milligrams per minute. Okay, and it says how many is he getting in 20? So we basically just multiply by 20 minutes. And he's getting, what would it be, 120? Yeah. Okay, that's 120 milligrams. Day supply, once again, we have 2 numbers. We have 2 and we have every 4 hours. Every 4 hours is the same thing as 6 times a day. So he's taking 6 times 2, he's taking 12 tabs per day. That's terrible. Okay, But how many are we giving him? We are giving him 60. So basically you'll do 12 divided by, 60 divided by 12. Please tell me I didn't screw this one up. That's going to be 5. I screwed that one up. I don't understand. Maybe I got the wrong answer. I don't know. I'm going to look at it. It'll be fine. But, yeah, how did I mess up an easy one? 3.5 pounds. Goodness. 3.5. 20 milligrams per kilogram every 12 hours. Medication is available in a concentration of 33 milligrams per mil. How many mils will the infant require every 12 hours? Okay. So since it's a weight-based, I'm going to go ahead and convert that because it's based on kilos. So it's 3.5 lbs. And that is 1.6 kilos. How many milligrams per kilo are they getting? They're getting 20. So remember, when you do this calculation, that is every 12 hours. So this patient is getting 31.8 milligrams every 12 hours. So our drug is 33.3 milligrams per mil. And how many do we need to get this patient? We need to give him 31.8 milligrams. So that divided by 33.3 is 0.956 mils. Okay. .5 grams per kilogram. He weighs 145. The drug concentration is 40 grams per 150 mils. How many mils will the patient need? So once again, he weighs 145. I'm going to go ahead and start omitting this because it's just divided by 2.2. That's 65.91 kilos. They're getting 1.5 grams per kilo. So they will need 98.9 grams. Okay. So our drug is available 40 grams per 150. So 40 grams per 150 mils, but we need 98.9. So we need to do 98.9 times 150 divided by 40. So that's 370.9 mils. Okay. Okay, so this one's a little tricky. We have, and please tell me I didn't mess this one up. So we have dose 1, 4 milligrams per kilogram per week. Dose 2, 3, and 4 is 2 milligrams per kilogram per week. The patient weighs 70 kilos. How many milligrams of Herceptin has the patient received after 4 weeks? So what you need to do here is understand the fact that the patient weighs something, right? The patient weighs 70 kilos. Okay, 70 kilos. So they will get 4 milligrams per kilogram per week. For the first week. And then 2, 3, and 4, they will get 2 milligrams per kilogram per week. Okay, so just remember, that is in 1 week. Okay, so second, third, and fourth week, they're all different doses. So they still weigh 70 kilos times 2 milligrams per kilogram per week. But remember, that answer you're going to have to multiply by 4 because they get it for by 3, second, third, and fourth. Okay, so we have a 4-week window. The first week they're getting double, so 4 milligrams per kilogram. And then week 2, 3, and 4, they get half of that. So 70 times 4 is 280. And 70 times 2 is 140 times 3 is 420. So what is 420 plus 280? Right? Because this is his first week, and then this is his second week, and this is week 2, 3, and 4. So he will get this much. So we need to do 420 plus 280, and we will get 700, and I believe that's grams, or milligrams. Okay. So that one was a little tricky, just based on the verbiage, but he is getting double the dose for his first week, and then the remainder of the 4-week course, he will get half of that. 28 tablets total. He takes 1 by mouth 4 times a day. So he basically just takes 4 a day. So 28 divided by 4 is 7. I did not screw that one up. Okay, I already see a weight. This is probably a weight-based. It says 3 days, 122 pounds. Day 1, okay, so it's going to be kind of similar. Day 1, he's getting 10 milligrams per kilogram. Then he gets 5 milligrams per kilogram 6 hours later. Days 2 and 3, he will get 5 milligrams per kilogram. What is the total amount of drug in grams that the patient will need over the course of treatment? Okay. How much does the patient weigh? He was 122. I need to divide that by 2.2. Okay. He weighs 55.5 kilos. Day 1, he's getting 10 milligrams per kilogram. So on day 1, he will get 555 milligrams. Okay, but that's just day 1. He will go to 5 milligrams per kilogram 6 hours later. So, that's I assume that it'll be starting at midnight. So this one starts at 0600. Okay, I think that this one is missing some info. I'll take a look at that one because I believe that it's missing 5 milligrams per kilogram per day right here. I could be wrong. We'll take a look at that one. .5 liters. Okay, this is an alligation problem. So this one relies on you understanding that D5W, D45W, and SWFI, those mean something, right? We already discussed that. We need to make D5W. So what goes in the center of my alligation? It's a 5. What goes in the top? It goes 45. And because it's SWFI, that means water, and that's 0. So 45 minus 5 is 40, and then 5 minus 0 is 5, and then you add those up, that's 45. Okay, so how many mils are we making? We're making 2.5 liters, which is the same thing as how many mils? 2,500. So we have 5 over 45 times 2,500. And then on this side we have 40 over 45 times 2,500. A lot of 2's. So yeah, 278 of the D45, 220, yeah, of SWFI. Another alligation, 16 ounces, 20%. We have 80 and 8%. How many mils are needed? Okay, so right here we have to remember 16 ounces is how many mils? There are 30 in each ounce. So that turns into 16 times 30. That is going to be 480, which is also the same as a pint, if you remember. So that's how many we need to make. So let me draw my alligation table. What are we trying to make? 20. Okay. 80 minus 20 is 60, 20 minus 8 is 12. We add those up, that's 72. And if you're unsure of where I'm getting that, it's just the top and the bottom added together. So 12 plus 60 is 72. That's how many parts total we get, because the 12 is how many parts of that solution. 60 is how many parts of that solution. So put them all together, because we're all mixing them together, 72 parts total. So once again, we have 480 mils. So it turns into we'll call that 80. And that's 400. Okay, and those are our answers. 400 mils of the 8%, 80 mils of the 80%. Weight-based, 130 pounds. 300 mg per kg and 50 of D5. How many will we receive in 24 hours? So I have 130 pounds. How many is he getting per kilo? He's getting 300 milligrams per kilogram. And remember, even though it says 350 milligrams per kilogram in 50 mils, we have to remember that we need to evaluate the drug, but then we can remember that it was in 50 mils. So he will get 300 for every kilo he weighs. He weighs 59.1 kilos. So that was a huge number. Okay, I'll go with it. Every 4 hours. Okay. So how many times does every 4 hours happen? 24 divided by 4. That's 6 times a day. So I need to do my 17,730 times 6. Whoa, that's a large number. Just to be clear, I did this times 6, and I got that. But it's asking for it in grams, and you can probably see that you'll just divide this by 1,000. I'll just write it out. Divided by 1,000 is a more reasonable 106.38 grams. So 106.4. That was a huge number, but we dialed it back just changing its units. Alligation, I'm going to go ahead and draw it. We have 2 and 10, we need to make 5. 10 minus 5 is 5, 5 minus 2 is 3. Add them together, and that's 8. How many do we need? We need 250 grams. And that is 156.3. $156 of the 2%, and then 94 of the 10. Okay. Patient needs 4,400 units per kilogram per hour for a 12-hour infusion. They weigh 172 pounds. How many units will they receive over the entire 12 hours? So on weight base, we're always going to calculate our patient's weight in kilos. 172 pounds. So that's 78.2 kilos. How many does he get? How many units does he get per kilo? It's 4,400. So that turns into a huge number, 4,399.99. 343,999.99. And remember, that's units per hour. Okay. So we'll get a huge number again because that's per 1 hour, and he's getting it for how many hours? He's getting it for 12. So we need to multiply this by 12. My little calculator barely holds that many numbers. 4,127,999.8. That is 4.127 million. So that's my closest number right there. 10 micrograms per kilogram per minute. He weighs 70 kilos. We don't have to convert. The total dose the patient has to receive is 21 milligrams. How many minutes must it go for the patient to get the dose? Okay, so this one's a little backwards. So he weighs 70 kilos. And he is supposed to get 10 micrograms per kilogram per minute. So he gets 700 micrograms per minute. Okay. It says the patient is supposed to get 21 milligrams total before we stop it. So how long does that last? So once again, I have milligrams for the dose that they need to receive, and I have micrograms for the dose I have. I'm going to go ahead and convert my micrograms to milligrams. And as you remember, micro is 1 million, milli is 1,000, so we just take off 3 decimal places. So it turns into 0.7 milligrams per minute. Okay. So that's how many milligrams per minute he's getting. He needs 21, so we have 0.7 milligrams in 1 minute. He needs 21, is that right? 21. How many minutes is that going to last? Or is that going to take? 21 divided by 0.7 is 30 minutes. Perfect. $750 milliliters. How long are we? Every 6 hours. What should it be set for in mils per hour? We have 750 divided by 6. Boom. Day supply, amitriptyline 25, we're giving him 30. He's taking 1 tablet every night. So 1 tablet every night, obviously 30 days if we give him 30. Pediatric patient order is 70 micrograms per kilogram every 12 hours. They weigh 33 pounds. It's available as 1 milligram per mil. How many mils will be needed over 24 hours? Okay, so weight-based, we need his weight in kilos. 33 divided by 2.2 is 15 kilos. He needs 75 micrograms per kilogram per 12 hours. So we're going to multiply that. That's 1125 mcg per 12 hours. So that's how many are in 12 hours. So we need to be knowing how much it is in 24. So we need to multiply by 2. Because there's 2, right? So times 2. That's 2250 50 mcg per 24 hours. Okay, our drug is available as 1 milligram per mil. So it's in milligrams. We are currently in micrograms. Just like the previous problem, we just need to take off 3 decimal places. So 1, 2, 3, that turns into 2.25 milligrams in 1 day. What is the drug supplied in? It's in 1 milligram per mil. So it's literally just 2.25. Okay. We're giving him 60. He takes 2 tablets by mouth 3 times a day. So 3 times a day, twice daily is 6 total. He has 60 tablets. He's taking 6 a day, so that turns into 10. Didn't screw that one up either. Patient is receiving 250 mils, 33 drops per minute. It's calibrated for 10 drops per mil. We're looking for time in hours and minutes for the bag. Okay. So if we're sending 33 drops per minute, I don't know how many mils it is, right? Unless I use my conversion. So this is mils. And we need to know our drop conversion, which I already forgot it. It's 10 drops per mil. So 33 divided by 10 is 3.3. So for every minute is 3.3 mils. I'm sorry, every minute 3.3 mils are going by. Okay? Or whatever. You get it. So we only have 250 mils available. So I'll put per minute. We only have 250 mils. We need to know how many minutes that's going to last. So for every single minute, 3.3 mils for every minute, 3.3 mils are going out the bag. So 250 divided by 3.3 is 75.8. Okay, so we know that 75.8 is more than 1 hour, because 75.8 minus 60, because we're taking out an hour, is, why am I doing this? 15.8 minutes. So it's just 1 hour and 15.8 minutes, which is that one. Succinylcholine available 20 milligrams per mil, 1 10 mil vial. The order is for 40 micrograms per kilogram every 5 to 10 minutes, who weighs 190 pounds. Okay. So each dose. How much does he weigh? 190. He weighs 86.4 kilos. He gets 40 micrograms per kilogram. Every 5 to 10 minutes. Now, the time does not matter. if you're confused as I am looking at the time, it doesn't matter because it says for one dose. Okay, so it's 34.54 in one dose. So, and that's micrograms. So if you remember, we're just going to have to divide by 1,000, which is 3.45 milligrams. Okay, so 20 in 1 mil, and we have 10 mil vial, doesn't matter, 10 mil vial, 20 milligrams in 1 mil, and we need to know how many mils contain that amount of drug. So it's 3.45 divided by 20, 0.173 mils. Boom. So if you got as confused as I did because it said time, don't be. It doesn't matter because it's for one dose. All right, so let's wrap it up. Potassium chloride ordered 0.5 milliequivalents per kilogram per hour. They weigh 154 pounds. The label, 2 milliequivalents per mil. How many mils are needed for 4 hour in 1,000 mils? Okay. Since it's weight-based, go ahead and do the patient's weight in kilos. They weigh 70 kilos. And they need 0.5 milliequivalents per kilogram per hour. So they need 35 milliequivalents per hour. Okay? So our potassium chloride is 2 milliequivalents per mil. But if you notice, it says it's in 1,000 mils. Okay. Oh, I don't even need to do this calculation because it's 2 milliequivalents per mil. So we just need to know how many in 4 hours because 35 in 1, so 35 times 4. 140 milliequivalents per every 4 hours. It's 2 milliequivalents per mil. So that's 70. Yep. (800 milligrams per kilogram per day, 7.5 pounds. It's available as 100 milligrams per mil. How many mils are needed? So, once again, 7.5 divided by 2.2 is 3.41 kilos. He needs 800 milligrams per kilogram. And that's how many milligrams per day? 100 milligrams per mil. Boom. 50 mil contains 500,000 units of this drug. The rate is 120 mils per hour. How many minutes will it take to infuse? Okay. So we have 500,000 units. In how many mils? 50, right? So this calculation will tell you how many units are in one single mil. Okay. He orders 120 mils per hour. Okay. So, if it's 120 mils per hour, this calculation will get units per hour. Units per mil. No. No. This is super easy, and I'll tell you why. It's just a 50 mil bag. 120 mils per hour, and you're seeing how fast it's going to deplete the bag. So it's literally just 50 divided by 120. .4167 hours, and this is where it gets tricky. You have to understand that 0.4167 hours is not just 41 minutes. Okay, 1 hour, 60 minutes. So you're going to multiply that by 60, and you're going to get 25 minutes. Okay. So all that other stuff was just filler and a distraction, and it worked. But please understand that you already have the volume and you already have the rate, so it's just going out the bag. 139-pound patient, medication dose of 125 milligrams per kilogram per 24 hours. Concentration is 425 per 2. How many mils are needed? 139. And they get 125 milligrams per kilogram per 24 hours. That's milligrams per 24 hours. So it's 425 per 2. There it is. Another dilution. How many do we have? We're almost there. Another dilution. So right here is a little bit different because it's proportions. So just remember, a 1 to 200 is the same thing as writing 1 over 200. But when you do that operation in your calculator, do not be confused because that is 0.005. Okay, I'm going to go ahead and write the other one. 1 to 2,000 is 0.0005. But that is not a percentage. A percentage is times that by 100. So you just move the decimal 1, 2, so that's 0.05%. That is 0.5%. Okay? So that will change your answer if you did not do that. So we need a 1 to 1,000. Okay, that's our desired. So let's set up our table. So don't forget your zeros. So you add them together, and you'll get 0.45. How many mils are we making? We need to make 60 mils. That's the answer. But you have to remember, if you do this, this is attached to this one. Okay, so that's a 1 to 200. So don't lose your ingredients because you converted them to percents. So 37 units are going over 1 hour. Insulin is added to a 250 ml bag. What's the what infusion rate should be used if it's set for 10 drops per ml? Oh, I see. So that's saying 37 units. Are in a 250 ml bag. So 37 divided by 250 is 0.148 units per mil. Okay, that's going over 1 hour. So that is going to be 0.148 units per mil divided by 60. And then you'll just do times 10. No. Oh. I did not need units. I don't care about units. All I care about is the mils. 250 mils over an hour is how many minutes? 250 divided by 60 is 4.17 mils per minute. Okay, that's mils per minute. I have a conversion of drops per mil. So that turns into 41.7 mils canceled drops per min. Another one, saved by multiple choice. $500 ml bag, 100 mils per hour, 500 mils for 24 hours. Okay, so it's basically saying if we're doing 500 ml bags divided by 100 mils per every hour, this is basically going to last 5 hours. Okay, so we're going to push it over 24 hours. So 24 hours divided by 5 hours, because that's how many hours our bags last. 24 divided by 5 is going to need 4.8 bags. Okay, if we rounded that to 4, would we be at an appropriate level? No. We need to round up because we need to have some left over to satisfy it. So that'll be 5. So we're giving him 20. He takes 1 tab by mouth daily. So he takes 2 a day. So 20 divided by 2 is 10. Okay. Drugs and drug class. So this is where I kind of threw some stuff together, but atenolol is a beta blocker, right? Because OLOL. I'll just highlight. Thiazide, Tylenol, Prozac, ampicillin. Okay. That's a beta blocker. This one is a diuretic. So people use it for, water loss. They call this a water pill. Orthotricycline is a contraceptive or birth control. Tylenol 3 is acetaminophen with codeine. And so if it has codeine, it is a opioid pain reliever or an analgesic. Prozac is fluoxetine, and that is an SSRI antidepressant. Ampicillin, that ends in -cillin, so that is a penicillin antibiotic. And Prilosec is omeprazole, which means that it is a proton pump inhibitor, or PPI. So at 50, 20, we need 800 over 33, okay? We have 50 up here, 20 down here, and 33 is our desired. 50 minus 33 is 17. 33 minus 20 is 13. You add those together, and that's over 30, over 30. And how many mils are we making? 800. Oh, I messed up. $346. No, that's not right. Was this one that I was missing a number? I should have 453 of the 20%. So this one I need to correct. And I should have 346 of the 50%. So that one's good. This answer is just not right. So I need to change that answer. Oh, that's the one I wrote on the board. Okay. Tossing that one. Okay, so this is catching my eye right now. 4 ounces. 7.5. How many ounces of a 10% solution will we need? Okay, so really it caught my eye because I thought I was going to convert it, but I'm not going to because it's asking for answers in ounces, so I'll just keep it that way. So we have 7.5, 10%, and then don't let me forget water. Okay, so my alligation table, 10, 0, 7.5. So this is 2.5. And this is 7.5. This is 10. This is 10. Okay, we need 4 ounces, right? So 7.5 over 10 times 4. 2.5 over 10 times 4 as well. This will be 1. Okay. 3 and 1. Ivy is running 50 mils an hour. 500 mil bag, 180 mil equivalents. How many mil equivalents are they receiving per hour? Okay, so we have 180 in the bag. So if we have 180 MEQs in the bag of 500 mils, we can calculate how many mil equivalents per mil. 0.36 mil equivalents per mil. It's going 50 mils per hour. So times 50 that is going to be 18 MEQs, and my mils, that's per hour. And that's the answer. Okay. So this one is sort of a trick because it's a Z-Pack regimen. So they're going to take 500 milligrams on the first day. Then they're going to take 250 milligrams a day for 4 days. So how many grams are they taking total? But I'll tell you this right here, and I kind of felt silly when I typed this question because they're getting 1.5 grams, right? They're getting 1.5 grams over how many days? First day, and then for the next 4 days. So 1 plus 4 is 5. And that's how a Z-Pack works. I don't know if anyone has been prescribed a Z-Pack. You take 2 on the first day and then 1 a day for the rest. And it ends up being 5. $39.5 milligrams per mil, 10 mil vial, 35 milligrams per kilogram per day. They weigh 109 pounds. 109 divided by 2.2. That's how many milligrams he needs in a day. Okay. Ours is 3.95 milligrams per mil. I'm sorry, 39.5. There it is, 43.85. Okay, 1 milligram per mil, 49 pounds, 100 micrograms per kilogram per day. How many mils will they receive in a day? Come on. Hundred micrograms per kilogram. We need to go ahead and convert to milligrams because our drug is in milligrams, so we're going to divide by 1,000. So that's 2.23 milligrams. Our drug is 1 milligram per mil, so that's literally just divide by 1, and that's 2.2. Okay. I believe that this one is another alligation because we have 2 percentages and we're trying to make one in between. So we have 30, 85, and we're trying to make a 60. But 3 liters, so don't let that trick you. So it's 3,000 mils. So 30, 60, 85. $85 minus 60 is 25. 60 minus 30 is 30. So this is over 55, right? 30 plus 25. I think that's right. And how many liters? 3 liters. But we need it in mils. 1,363.6 mil. Okay, so 1636 of the 85 is what I should get. 1636 of the 85, 1363 of the 30. 500 milligrams in 20 minutes, 50 mils containing 500 milligrams. What rate in mils per hour should it be infused? Okay. So there's 500 milligrams of the dose administered in 20 milligrams. I'm sorry, in 20 minutes, and it has 50 mils. So there are 500 milligrams in our 50 mil bag. Nope, I'm going to fall in the same trap as I did last time. Milligrams does not matter because it's dispersed evenly in this bag. So it's literally just 50 mils. And what time did it infuse in? 20 minutes. 20 minutes. It's not liking my pen right now. 50 divided by 20. 2.5 mil per minute. How many mils per hour is that? So, sorry, if it's 2.5 mils in 1 minute, how many minutes are in an hour? That's 60. Boom. 50 mils, 3.5 grams, 200 mils an hour. What is the infusion rate in drops per minute if it's 10 drops per mil? Okay. All right. So 200 mils an hour. You want it in drops per minute, okay? Mils an hour. Oh. If there is 200 mils in 1 hour, which is how many minutes? 60 minutes. How many mils are going by in a minute? 200 divided by 60 is 3.33 mils per minute. Okay. So that's mils per minute, and we have a calibration at 10 drops per mil. So if we have mils, we just need to multiply it by 10 drops per mil. That cancels, so you'll get 33.3 drops per minute. And I think that's it. Okay. So real quick, let's talk. We're going to do something about the math. I want to give some of you an opportunity to maybe correct some mistakes that you made. As you've seen, even me sitting down taking it, there were some mistakes that I made, but I corrected myself with multiple choice. So I understand how that works. But really, we need to get this down because this is going to be something that haunts us for next semester. So please take a look at this video, watch it a couple times, write it down, whatever you want to do. We will talk about this on Monday. So hopefully you are all watching this. Hopefully you got to the end and you're not asleep. And I will see you all Monday. Thanks.